class. So we are going to cover Chapter 7, Predicting Double Displacement Reactions. And as you can see right here, we have calcium chloride, aqueous, meaning it's totally dissolved in water, it would look clear. And then we have sodium carbonate, aqueous. And typically in double displacement reactions, your reactants are aqueous. And then when you're doing a double displacement reaction, you need a solubility chart so you can predict if you form a solid, liquid, or gas. Because the solubility chart will tell you if something is insoluble, then you are going to form a solid. And if you form a solid, then you have a reaction. If you use the solubility chart and you find aqueous, aqueous, then you write no reaction, and it becomes really easy. But in this particular case, when you do the double displacement, the cation on the far left and the anion on the far right are going to combine. And the cation in the second ionic compound and the anion in the first will combine. Their charges do not change. So the first thing that you want to balance when you draw the products are the charges. You want to balance the charges. And calcium is +2, carbonate is -2. So those go together 1 to 1. Sodium is +1 and chloride is -1 based on the groups that they're in. So again, those are 1 and 1. It doesn't matter that you had 2 sodiums over here and 2 chlorides over here. You have to balance the charge first, and the charges do not change in these reactions. So then when you look at a solubility table, you're going to see that anything that's in group 1 of metals, sodium, lithium, rubidium, they are all soluble. And soluble means aqueous, so that means that they don't react. They stay ions. But you'll find that the calcium carbonate forms a solid. And because you have a solid, you do have a reaction. Now, most liquids and gases will be formed from acid-base reactions, which are still double displacement reactions, but it is a separate type of double displacement. So you look for the acid, and you look for a metal hydroxide to know if you have an acid-base reaction. And this one, it's just a pure double displacement. We do have a reaction because we formed a solid precipitate. Solids and precipitate, same thing. And we do need to balance the overall equation. So I'm going to put a 2 here because I can see 2 sodiums on this side of the arrow and 2 chlorides on this side of the arrow. So I've now made 2 sodiums, 2 chlorides. I have 1 calcium on this side of the arrow, 1 calcium on this side of the arrow. And then I have 1 carbonate on this side of the arrow and 1 carbonate on this side of the arrow. So what I have here is my molecular equation. Now, if they asked for my ionic equation, everything that's AQ gets pulled apart into its ion, and you write an AQ next to the ion. So calcium chloride is AQ. So I'm going to do calcium, its charge, AQ. Chloride, now notice the chloride does have 2, but when you pull it apart, you put the 2 in front. There's my chloride, 2 chlorides, AQ. Again, on the reactant side, everything tends to be AQ for double displacement. 2 sodiums, AQ. 1 carbonate, AQ. Notice that they all have charges. I put the proper charge on them. Then what I form, and watch this step carefully, because I cannot pull apart my solids, my liquids, or my gases. So I had to write calcium carbonate as a solid and keep it together. Then the sodium chloride that's on the product side, I'm going to write over here. Those I can pull apart because those are AQ. Since they are exactly the same charge, same form, on both sides of the total ionic equation, they are spectators, meaning they don't form any new bonds. They're merely there as ions floating around in the same form the entire time. Once you get rid of spectators, what you have left is your net ionic equation. And your net ionic equation